popular. And so in an effort to capitalize on some of that positive market buzz, Sun Microsystems and Netscape shared. When Microsoft released its first version of Internet Explorer several months later, they wanted to support not only all of Netscape's HTML elements and all of its CSS selectors, they wanted to implement that really cool scripting language they had as well. The only problem is that Sun wouldn't grant Microsoft rights to the name JavaScript. So Microsoft did a clean room re-implementation of JavaScript, and they named it Vbscript, absolutely, but they named it JScript as well. So there was Vbscript you could run in the browser as well as JScript. Vbscript was meant to be obviously a watered-down, light version of Visual Basic, but JScript was meant to be a version of JavaScript. And that's when the problems began. Because now Netscape was developing JavaScript and Microsoft was developing JScript, and at that same time, their market shares were trading places. So Netscape, the company that invented JavaScript, saw their market share going like this. Microsoft, who was second to the party, saw their market share going like this, and they had this thing called JScript, and they could do whatever they wanted with it. And so Netscape said, you know what, we've got a problem here. We're in danger of losing control of the language we created. So they went to a standards body. They went initially to the W3C, the World Wide Web Consortium. And the W3C said, you know what, we're spending our time focused on documents. We're spending our time focusing on HTML and XML and CSS and things like that. We have no interest in standardizing a programming language. So Netscape went to a number of different organizations. They went to IETF, but they eventually landed with the European Computer Manufacturers Association, ECMA. It sounds like a skin disease, doesn't it? Yeah. But ECMAScript is the standardized version of JavaScript. ECMAScript is the specification that allegedly JScript supports as well as JavaScript. So this notion of having different JavaScript engines out there is very important as well. We can say they all implement ECMAScript to a lesser or greater degree. ES3, ECMAScript 3, is basically what IE6 supports. So ES3, ECMAScript 3, has been with us since the late 90s. ECMAScript 4 never made it out of committee, but ECMAScript 5 did. And most modern browsers now, whether it's V8 or Nitro or SpiderMonkey or any of those, we can all say are comfortably ES5 or ECMAScript 5 JavaScript engines. Just like Java has different versions coming out. We're in the era of Java 7 right now, but Java 8 is on its way. We're in the era of ECMAScript 5, but ES6 is on its way out as well. And later in this workshop, when we're talking about modules, we'll get to refer back to ECMAScript 6. But as a JavaScript developer, as a web developer, it's really not enough to say I'm running in Internet Explorer or Chrome or Firefox. We need to have a good understanding of what JavaScript engine we're dealing with, as well as what version of ECMAScript those different JavaScript engines are compliant with. Does that make sense? Yeah. So, getting back to V8. There it is. Playing mad scientist up here, losing my slide clicker already. It's early. It's only 20 minutes into the talk and I've lost it once already. So looking now up here at Chrome with V8, which is what Opera is going to use as well in the next release. Looking back at that now, we can come back and we can see that what Node.js really is V8 running headless. What we really find is that the very same JavaScript engine that you'll find in Google Chrome is something that you can run outside of the browser. And this brings so many interesting capabilities. It allows you to run an entire web server that was written in JavaScript. No longer do we have to deal with Apache and an external module, or Tomcat and an external module, or anything like that. We can run in a web server that is written from the ground up in JavaScript. Now we have to realize that JavaScript isn't running client-side, it's running server-side. So you do have lifecycle issues to think about. But V8 is generally recognized as one of the fastest, best engineered JavaScript engines out there. So V8 Node is an incredibly fast JavaScript environment. But we've had JavaScript available to us from the command line in Windows since Windows ME. We've had JavaScript available to us on OS X for quite some time as well. If I were to come in here and type in JS, I can start doing things like and oh, it didn't like that. All right, let's try this. There we go. So this is me running JavaScript outside of a browser. Let me out. I want to be gone. There we go. So this is not Node. This is Node. But being able to run JavaScript and do exactly what I did before is very helpful. Now, many of you are probably used to doing this from a JavaScript console. But what you have to realize when I'm using this developer console right now, I'm in Google Chrome, so I am using V8 to essentially test out this code. So many times, if I've got a browser open, I'll just pop up a console, explore with some code, play around with it. This is called a REPL, by the way. If you don't know what REPL stands for, read, evaluate, process loop. And so being able to have a simple runtime environment, a simple REPL in place, this is a V8 REPL, but it's inside of the browser. This is a V8 REPL, but it happens to be Node.js. Any questions so far? Good? Super. So you're going to be able to do all the things in JavaScript that you would normally be able to do. You'd be able to create a new object. You'll be able to make Ajax calls. You'll be able to do all those kinds of things. But what you won't be able to do is select all of the LIs out of a UL. What you won't be able to do is select all the paragraphs out of your document or all the anchors out of your document and do something like that. What that means is something like Phantom.js becomes incredibly useful as well. Because just as Node.js is running your JavaScript engine outside of the browser. Knowing that Google Chrome used to, and Safari still does, run WebKit as their render engine, you can run Phantom.js outside of your browser and run all of your unit tests in there, whether you're using Mocha or Chai or any of the other JavaScript libraries out there. Phantom.js is your DOM. Now, it may seem weird running a DOM that you can't actually see, running a document that you can't actually visualize. But again, if you think about running your unit tests, if you think about running it server-side, Phantom.js becomes an incredibly powerful tool in your arsenal. And what's really neat about Phantom.js is if you do want to try to visualize what's going on, if you do want to actually see it, Phantom.js allows you to write out your web page as either a scalable vector graphic, an SVG, or a PDF. So what you can end up doing is programmatically requesting a web page. This is what it would end up looking like. You have to require a web page. By the way, a web page is a module. It's a common JS module. So what you're doing is you're requiring that web page, you're importing it, you're creating that web page, you're visiting this URL Phantom right here. When you open it, it's an asynchronous request. All of JavaScript is asynchronous. So when that comes back, this function will get invoked. You'll be able to tell if you get a 200 OK, or 404 not found, or 201 created, or authentication required, or any of those kinds of things like that. And then you can do whatever clever stuff you want, write your assertions inside of there, and then actually call exit to exit your browser. Phantom.js doesn't run inside of Node. It actually runs next to it. But you can end up using Phantom.js on any one of those different JavaScript engines to play around with it. Any questions about Node or Phantom at this point? No? Yes, sir?
So is unit testing the only benefit in testing, or is there any other applications where these two can be used?
So unit testing, now I'm going to give you, we're going to spend the entire day dealing with Node.js. Node.js has a lot of value outside of simple unit testing. We're going to use it to run volo.js, which will allow us to import new libraries. We'll use it to run uglify. We'll use it to run JSLint. We'll use it to run a variety of different things. So your question is very good. When it comes to Phantom.js, I've only used this exclusively for unit testing. Once I'm dealing with a headless WebKit or a headless render kit like this, the only real use case I've found for it is running unit tests against it. I've often thought that if you had some need to just send something URLs and have it render that page and write it out to PDF, that would be a really nice use case for that kind of thing. But almost exclusively, I end up using this for unit testing. Very good question. Thank you. Wonderful.
Why uglify on the server-side script?
Ask me one more time.
Why uglify on the server-side script?
Oh, we'll talk about uglify later on, but it's really a performance optimization is what it is.
It doesn't get transferred to the client.
It does get transferred to the client, yep. So what you'll be running is it's a code optimizer. It's analogous to Java C compiler. And so since JavaScript isn't compiled, when we uglify something and when we minify it, those two different utilities are performing the same functions that a Java compiler would be running. Yep. So we'll definitely be talking about that. We're talking about different uses for Node.js and for Phantom.js. This, once again, these are 4 different companies that are using Node.js, but I think it's really interesting because it is being used in a very different way in each different company. Cloud9 is literally an IDE. If you're using Eclipse, if you're using Visual Studio, if you're using IntelliJ, those are all IDEs that are written in Java or written in C# or different things like that. There is now a JavaScript IDE written in JavaScript called Cloud9. It's really a powerful thing. Now, I'm not using it in production, but where it gets especially interesting is when you start thinking about writing your code in the cloud. I have local text editors, which is why I haven't used it, but if you wanted to be able to log into a website and begin writing your code and doing all of that on the server side, something like Cloud9 would be something you could use. Of course, you can also run it locally. So Cloud9 has nothing to do with web development. It's a tool that you would use to write your web pages. eBay. Now, eBay is using Node.js for its evented IO model. As you can imagine, eBay, when I've lost this, I've put it right here. You'll help me remember it? Okay, good. eBay, obviously, is all about the auctions. eBay is all about these very time-dependent things going on. And threading is an incredibly difficult problem. So what JavaScript does to solve that incredibly difficult problem is not be multi-threaded. JavaScript is a single-threaded environment. So you start thinking to yourself, oh, well, then it can't be very fast. We've often said that the compiled languages are much faster than interpreted languages. And while that is true, generally speaking, Node.js, in side-by-side comparisons with all the other major web servers, tends to come out at the top of the heap, tends to outrun different web servers in terms of raw performance. And part of what they say is because it doesn't have to spin up multiple threads, which is very expensive to do from an operating system perspective, and manage those threads and manage different stacks and heaps and things like that. When Node.js comes up, it has a single thread to worry about, but what it does is it asynchronously deals with event handlers. So what that means is you can queue up a bunch of event handlers, and the minute that event fires, it's there ready to respond. And so what eBay has found Node.js brings to the party is an incredibly performant web server that ironically uses an interpreted language. Very interesting. JavaScript is not slow natively. It was slow based on the 20th century JavaScript runtimes that we had. The ECMAScript 3 engines were very slow. They didn't have just-in-time compilation. They didn't have hotspot optimization. They didn't have all that. V8 was the first modern JavaScript engine that brought literally orders of magnitude performance gains. And then Nitro came along, and then JagerMonkey came along, and now we have a whole different kind of JavaScript that runs, in many cases, as fast, if not faster, than corresponding Java code. So Cloud9 is an IDE. eBay is using it for its event model. Yahoo is using it. I spent 9 months at Yahoo running all their developers through HTML5 training, making their websites mobile ready. And they have a number of different libraries out there. You've heard of the YUI, the Yahoo User Interface Toolkit? Yeah. Well, the YUI is a series of different components. You might say, well, I need this accordion widget, and this Ajax widget, and this drag and drop widget. And so you would do 3 different script statements at the top. Well, what Yahoo is doing with Node.js is getting those requests and saying, do I already have a version of the library that has those 3 components in? I will very quickly either pull it out of cache or build that combination of that JavaScript and send it downstream and then put it in cache. So even though you're using YUI in Ruby on Rails, or you're using YUI on the CLR, or you're using YUI inside of Tomcat, you're in fact using Node.js to bundle, to uglify, to minify, to package all those libraries up and send that downstream. So Yahoo was using it as a dependency manager solution. Voxer is a voice company. They're dealing with things like voice over IP. That was hard for me to get out. VoIP. So what Voxer is doing is they're saying, we have a bunch of web services in place. We're sending out JSON, JavaScript Object Notation. They said, since we're building a JavaScript API, wouldn't it be nice to use JavaScript all the way through the stack? JavaScript on the client side as well as JavaScript on the server side. Now, we're using Java on the server side and JavaScript on the client. Or we're using C# on the server side and JavaScript on the client. So a large part of what we end up having to do on a daily basis is transform our Java collections into JSON lists. We have to transform our C# collections into JSON and send it downstream. What we're finding is there's a whole new category of persistence engines like CouchDB, like MongoDB, that will send JSON down natively. You don't have to do that transformation. And they said for all of our APIs, for everything that we need to do server-side, it made more sense for us to do that in JavaScript. So we see that Node offers us a wide variety of capabilities, all of them beyond the simple web server that you would have expected. There are a number of different books out. I actually like getting started with learning Node. If you're looking for a nice introduction, learning Node gives you some nice kind of introductory things. Node Up and Running is a little bit more of an intermediate book, but it definitely brings those same concepts to the party. Now, Node.js in Action, I believe that they've actually shipped it. I've been reading a beta version of it. But the reason why I think Node.js in Action is so interesting is I always like reading books by the architect of a particular library or a framework, because that tends to give you a different set of insight. It tends to give you a better idea of what's going on. And one of the authors of this book, TJ Holloway-Chuck, he is not the author of Node.js. That's Ryan Dahl. We'll see a picture of him in just a moment. But TJ, this is TJ right here, is a major player in the Node.js world. He's released a web framework called Express. And if you're doing any kind of Node.js development, all of these books, Learning Node, Node Up and Running, they very quickly will have you install the Express web framework and begin running. TJ Holloway-Chuck was the founder, was the author of Express. He's also the founder of Mocha, which is a unit testing library. He's also the author of Jade, which is a templating library that's very popular. So when you start beginning to recognize names like TJ's, you'll never forget his name. It's a unique name to begin with. But when you see his name on a book, it's no guarantee that he's a good author. But what it is a guarantee of is you'll get some really interesting insight from someone who is very close to the problem. So some nice resources for you. What I like about Node is that it's completely cross-platform. There are node installers for Windows. There are node installers for OS X. There are node installers for Linux. You can also download the source code. V8 is a C project. So if you're used to dealing with open source, you're used to downloading the source, doing the .configure, make, install, dance, and build it from source, you can definitely do that. I will tell you that in the early days of Node.js, Windows wasn't a first-class citizen. That's true of a lot of open source projects, isn't it? That if you think of Apache, only when Apache 2 came out was it really certified for production on Windows. All of the Apache 1X stuff ran like a champ on Linux and OS X, but was a little bit flaky on Windows. Well, Microsoft recognized that, and Microsoft has been contributing serious amounts of code to this code base to make sure that Node is a first-class citizen on Windows just like those other platforms. That should be very helpful in building confidence. Now, I told you I'm a Java developer. And in Java land, we like talking about WARA quite a bit. Write once, run anywhere. And while that's true on Java, it's really true for JavaScript. Because not only do we have JavaScript available across all of the major desktop browsers, we have JavaScript available across all of the mobile browsers as well. Java definitely, you can run anywhere on the desktop, but you can't get Java running on iOS devices. You certainly can on Android. You certainly can on BlackBerry. But it's not a language that you can run across all your mobile devices. JavaScript is. You can run JavaScript on Windows phones and on your RIMs and on your Samsungs and Apple and Android as well. JavaScript is what you end up writing Flash in. Now, ironically, it's not the JavaScript you're used to dealing with. It's a derivative called ActionScript. But ActionScript is based on ECMAScript 4. Now, ECMAScript 4 never made it into the browser, but originally, Adobe had donated their Flash engine to Mozilla. And they said, this is what a modern JavaScript engine will look like. Now, that never made it into production, as I said, but it's what got Google and everyone thinking, we really can rewrite JavaScript engines. We really can apply modern concepts to it. So even though Flash is not JavaScript per se, it is an ECMAScript derivative. And it is more like JavaScript than unlike it. But you can use JavaScript to script up all your PDFs. You can use JavaScript to write all of your open office macros. In Microsoft Office, you would end up using VB to do your scripting, VBA, Visual Basic for Applications. In Open Office, you end up using JavaScript for all that scripting. And as a matter of fact, in the very latest version of Microsoft Office, you can use JavaScript as your macro language as well. Microsoft is all in on this HTML5 JavaScript stuff. When you find that you can't run Silverlight on a mobile Microsoft tablet, but you can run HTML5 and JavaScript, you have an idea of what Microsoft's strategic importance is around language. And JavaScript now is available to us on all of our smart TVs, on all of our Blu-ray players, on all of our DVD players, on all of our dumb TV enablers, all of our Apple TV, Google TV, Boxy Box, Roku boxes, all of those guys. We start looking at JavaScript in all the different places you can run it. It really paints a very interesting story. I like saying that we're in the third renaissance right now of JavaScript. The first renaissance was in 1996, when they said, oh my gosh, we got this thing called the web. Wouldn't this be fun actually being able to script it up? The second revolution of JavaScript happened in 2005, and that was the Ajax Revolution. That was, oh my goodness. Now we have things like Gmail and Google Maps and Flickr and all these different libraries that use JavaScript in a very different way. We're in the third renaissance of JavaScript right now. The fact that JavaScript runs across desktops, tablets, smartphones, smart TVs, and everything in between is very powerful. This oftentimes is my technology stack of choice when I'm coming into a new client. I'm using Node.js as a web server, and I'm using CouchDB as a persistence store. CouchDB is interesting because it stores everything native as JSON. Instead of writing SQL statements, select first name, last name from customer, where, city equals Bengaluru. Instead of writing SQL in CouchDB, I write MapReduce queries in JavaScript. So keeping JavaScript in my web server, keeping JavaScript in my database, keeping JavaScript in my client ends up providing a lot of unity. Even though they're running in physically separate JavaScript engines, having the same language run across all those different tiers is a really exciting way. Thank you for being patient. What's your question, sir?
Why do you prefer CouchDB rather than MongoDB?
The question is, why do I prefer CouchDB over MongoDB? No good reason. No good reason at all. MongoDB is an incredibly powerful persistence store. It's very popular. If you chose to run with that, I wouldn't argue with you on that at all. MongoDB, in order for me to interact with that, I need to have some kind of binary driver. What I love about CouchDB is there is no driver. It is fully RESTful from the ground up. So I make an HTTP GET request to it, and I get my JSON back. I do HTTP posts to do inserts. I do HTTP puts to do updates. I do HTTP deletes. And so why I like CouchDB is that it is truly of the web, by the web, for the web. It is RESTful all the way down. But MongoDB is a great solution. Cassandra is another one. React. There are lots of good ones out there. But if you're a web developer, this uses web technologies all the way down. Does that answer your question? It's very good. All right. Well, let's begin taking a look at Node.js for our server-side use, but then we'll get into Node.js for our client-side as well. Now, this is the canonical hello world from the Node.js website. So let's try to deconstruct it. Let's try to break it down line by line and make sure we understand what's going on. Whenever you see the word require up here, that is bringing in a different module. This is the equivalent in Java of doing an import. This is the equivalent in C of doing an include. So there's a whole HTTP library module that we can bring in. Now, it's not surprising that if you bring in the HTTP library, all of a sudden you can spin up a new web server. So you can see that once we've required it, we have a variable named HTTP. That object now has a series of methods I can call on it. One of them is going to be create server. A web server, by its very nature, is asynchronous, isn't it? A web server is meant just to stand up and hang out until an incoming HTTP request comes in. Now, once it does, it springs to life. When I create my server, I am passing in an anonymous event handler right here. I'm passing in this function that will expose the request and the response so I can do things like write out my 200. I can write out my response end. I can do those kinds of things. I'm doing this in line right now in here. This is a very simple web server. It's a very naive web server because whatever request comes in, no matter what, it's just going to send back hello world. Obviously, we would get much more sophisticated in here. But what gets lost out of all this is that this is an asynchronous server. When I call create server, it's got an event handler right here that's sending these responses back. We can see that it's listening on a particular port, it's listening on a particular interface. And then we can spit out something at the console. Let me actually run this for you so you can see what's going on. Here's my file, http.js. And I just wanted to show you that I've changed the code just a little bit here. When we come back and look at the hello world, we're saying HTTP create server and we're passing the function directly in. In this code, I wanted to show you that request handler is hanging out completely separate. All that request handler is meant to do is when you create the server, it is what's going to handle those incoming requests and write responses to the wire. You can see in this case I'm listening on port 8000 and I'm writing things out. So if I want to see this in action, here's my file, http.js. I'm going to type in node, http.js. Hanging out, listening on port 8000. Localhost. Hello world. Hello kids. Now I'm trying to refresh and I'm not seeing hello gids. I'm going to have to restart the server, aren't I? Yeah. So what happens when I typed in Node.js is that interpreted that JavaScript and loaded it up into memory. It's not reloading. This wasn't me just changing a simple HTML file, which, by the way, would have worked. That JavaScript, I need to bring it down and bring it back up again so I can now see hello kids. Now, there are a number of modules you can set up, watcher modules, that will allow you to keep that web server up and running. But I just wanted to show you what's going on with this code. Does that make sense? Yeah? Now, Node ships with a number of different libraries. Here's another example. Notice what I'm doing here is I'm bringing in not HTTP, I'm bringing in just a more generic net interface. I can still create a server, but in this case it's just listening on a socket. And what it's going to do is it's just going to pipe out whatever is coming in. This one's listening on port 9000. If I come in over here and I spin up two instances at the same time, but one that's listening on port 8000 and one that's listening on port 9000, I can start doing all kinds of interesting things. I can come in here and I can curl. $9,000, and I can say foo bar. We can see that I came around here and I made that request, but over here, I'm not flushing. All right. There we go. I was expecting that stuff to echo out, but I just wanted to point out to you here that we don't have just a web server running. We could have a simple network server running. We could have all kinds of different capabilities running here. But when you're doing something like Node example or Node HTTP or Node net or anything like that, you're running a series of scripts. Now those scripts that I were running were spinning up servers that were listening on ports. And again, this is what people think of when they think of Node.js. They think of it as an app server. And that's good. It's a very powerful app server. You should think of it that way. But we can also end up using it for client-side use as well. So, if you want to read the fine documentation, you'll find that there are a number of different libraries included with Node.js. if you install the JDK on your system, you'll get a Java-lang string library that allows you to do to uppercase and lowercase and trim and find and all kinds of things. You'll get a collection API that'll allow you to create array lists and hash maps. You'll get a network library, you'll get an HTTP library, you'll get a variety of things like that. Well, Node.js offers you those same types of things. When I come in, start looking at the API docs, you'll see that, oh, of course, well, I've got an HTTP library. And the HTTP library allows me to create a server. It allows me to create a client as well. It allows me to deal with responses. It allows me to deal with requests and gets and all kinds of things. So this is reading the documentation here and giving you some nice examples. But what's interesting is I have access to the file system. I have access to the operating system. I have access to the process itself. And this is where people start saying, well, wait a second. I thought JavaScript didn't have access to the file system. Well, you're right. If you're in the browser. If you're running JavaScript inside of a browser, it's running in a sandbox. It would be a huge security flaw if you had code that you were able to download from an untrusted source from anywhere on the net and have it go out and scavenge around on your hard drive. That'd be a bad thing. But remember, we're running outside of a browser. We're running headless V8. And so we absolutely can use JavaScript to walk a directory tree, to open up files, to read the contents of that file, to write it back out, to do these kinds of things. Running JavaScript outside of the browser will be one of the hardest things you'll have to get your mind around. Because you're saying, well, wait a second, this is the language I've been using for years. Yeah. But you're in a different environment now. And you have all of these libraries available to you. To be very clear, these Node libraries are not available to you client-side. The JavaScript you have running in browser has a bunch of libraries that aren't available to you in Node.js. The JavaScript running inside your browser will have a navigator object, will have a window object, will give you ways to go in and manipulate the DOM. Those are the JavaScript APIs, libraries, modules that are exposed to you when you're running in a browser. You won't be able to make Ajax requests. You won't be able to do DOM manipulation in Node.js because there's no render kit. You're running just V8, not Phantom.js. But because you are running V8, you'll be able to get access to the process, to the file system, to a lot of things like that. Same language, different libraries. Does that make sense? Yeah? And then we can see, well, what's the type of operating system I'm running on? What's my platform? What's my architecture? What's the release? This is all JavaScript, but I'm doing operating system level introspection. So if we want to see that in action, here's my good friend os.js. Yeah? And then in order to run it, I can see that I'm running on Darwin, that my architecture is a 64-bit Intel platform, and the release that I'm running on is 12.3.0. Are those the values you'd have expected to see? Yeah, me neither. Now I got something. If I was running this on Windows 7, don't worry, you would have been differently but equally confused. That's reassuring, isn't it? Yeah, if I'm running on Windows 7, it would come back and say, hi, I'm Windows NT. What? I thought you were Windows 7. Yeah. You know, and it tells you you're running on this platform, and I got that OS release right there. Now, we can get around that. These are actually the values that are returned by the uname utilities and a variety of different things like that. So while it's technically correct, they're probably not the exact values that you're looking for. So what we can do is use a different set of libraries. On the Mac, I've got a command line utility called swver, so software version. On Windows, I could run systeminfo. But if I run an SW version out here, I can see, oh, there's the more familiar OS 10, 10.8.3, the things that I would expect to show up. So how can I begin combining these values? I'm going to have to bring in a few more libraries. That shouldn't scare us. In addition to the operating system library, I'm going to bring in the sys library, and I'm actually going to bring in a child process library as well. Now, you have to realize that JavaScript is single-threaded, but V8 is written in C. And so I could spin up as many different threads as I want if I get my hand on the child process library and do these kinds of things. So what this allows me to do now is switch based on what operating system I'm running on. And if I come back as Darwin, what I can do is I can spawn a new thread. I can run swvers that I just showed you from the command line and get that output. If I'm on Windows, I can spin up a new thread and call systeminfo and get that information out. And if not, down here on the default, what I can do is what I would normally do, which is call those kinds of node libraries. So this is in a file called OS2, not that OS2, just the second version of this little library. Did any of you do OS2 development back in the day? Oh, I miss it. My dad retired from IBM. Those were the good old days. So if I come in here right now and look at this OS2 library, I can get those values. And once again, that's what it ends up looking like. About Node is how many third-party libraries are out there. And my slides are perpetually out of date. So let's come over here real quickly and see what our actual module count is these days. Oh, there we go. A mere 29,000 different modules out there. When I first started as a Java developer, I thought that I could learn everything about Java. I thought I could learn every single package. And in the Java 1.1 days, you could. It was achievable to at least have one example through all those libraries. Java got so complex I wasn't able to do that anymore. There are entire libraries I've never played around with inside of Java. And then all of those third-party libraries on top of it, yeah, there's no way. When I started with Node and I saw that I was already almost 30,000 packages behind when I started, it was about 18 or 19,000. So this is just meteoric growth, just explosive growth. That means that there are probably only about 355 packages that I would actually want to use out of here. But what's nice is that this exposes a lot of metadata so we can begin making those kinds of value judgments as well. So NPM is a package manager. This is how we can go in and install new libraries. Because when I installed Node.js, I got the HTTP library, I got the net library, I got the sys and the ls library. But I might want to bring in different libraries to start dealing with OAuth, or start dealing with LDAP, or start dealing with MongoDB. If I needed to install the MongoDB driver, I would say npm install Mongo, and that would pull in that library. So very quickly, you're going to need to reach out and get these kinds of things. Here's another name that you should be familiar with here. Because while Ryan Dahl is the creator of Node.js, after about 3 years, he kind of got burned out and stepped down. He's a classic developer that said, you know what, I liked writing the code. I really didn't enjoy going to conferences around the world and talk about how great my creation was. So he's kind of stepped down. And Isaac, our good friend Isaac, who created NPM, is now the leader of the Node project as well. This is what Isaac looks like. We need to be very afraid, don't we? He's a fun guy. So in order for these modules to work, we need to have some way to identify the version and what dependencies it might have. And this is all handled through a package.json file. Now we can see that package.json has a number of things that you would expect: a name, a version, a description. What's the main script that you need to execute in order to run it? What are some other scripts that we can use? What repo is it stored in? What's the author? What's the license? There are lots of different things out there in this package.json file. Now, this is required for Node.js. Any package that you're going to require up top has to have a package.json file associated with it. But what's interesting is this package.json is so compelling. There are a lot of client-side JavaScript libraries that have started using it as well. Now there is a cheat sheet out there hosted by the guys at Nodejs.com, that is an interactive way of dealing with this. So you could go through and actually hover over those things and see exactly what each one of those various elements are. But I want to step away from the actual file format. We'll come back to it in just a moment. I want to talk about something else that Node brought to the party, and this is very important. It uses something called semver, or semantic versioning. And this is really important for the success of Node. Every package has 3 digits associated with it: major version, minor version, and patch version. Now, if you've been doing software development for years, you know that this is a very common pattern, but Node enforces it. You have to use these kinds of things. Now, you don't have to follow the semantics of it, but the idea is, if you're on a 1.0 branch, any minor version should continue to run without breaking changes. If I'm on a 1. Version of this library, I should be able to run 1.1 or 1.9 or 1.99, and I should be assured that all those should be backwards compatible. That's the idea behind semantic versioning. The idea is, with each new release, you're adding new features, but you're not breaking the interface. If you are going to break the interface, if you are going to deprecate things like that, that's what the major version is for. I would expect 2.0 code to break in a 1. Library. I would expect 1. Code to break in a 2. Library. So having a major, a minor, and a patch version is crucial to the success for Node. Node pays attention to all these kinds of things. This semantic versioning is all through the package.json file. Now, if you wanted to create one of these package.json files on your own, you could hand create it as just JSON, or you could type in npm init. So if I were to come over here right now, if if I were to come in here and type in npm init, it's going to say, all right, what's the name of your library? I'll call it the GIDS 2013. What's the version? Well, I'll say we're at 0.0.1. We're just getting started with that. What's the description? It's a JS library to manage GIDS delegates. What's the entry point? What's the test command? Is it stored in a GitHub repo anywhere? What keywords are associated with it? Software, conference. Who's the author? Does that all look good? If it does, wonderful. And what we end up with then is a package.json that was written out for us. So it's trivial to let npm walk you through that simple little wizard and build one of these things up. I said it once, I'm going to say it again. I encourage anyone who's doing web development these days to associate a package.json with their file. It's a very convenient way to start throwing authors and email addresses and version numbers and dependencies and all those kinds of things. And the reason I recommend it is because when we go out and we start looking at I'm sorry, I thought I was going to show you examples of this here. Let me just hop out real quickly to the web and show you that there are a lot of folks out there that are using this, even though they aren't necessarily running inside of Node. Remember that little jQuery library I was telling you about? jQuery couldn't be more of a client-side library if it tried. Its whole purpose in life is to shellac over differences between that JavaScript render kit. So there is nothing about jQuery that ties it to Node.js, yet we come in and we see package.json hanging out right there. And they've used package.json just as a way to begin gathering up all the metadata about their particular library, including the dependencies and the developer dependencies that they use. So if we were to come into GitHub right now and start looking for Backbone, Backbone is a client-side library as well. Has nothing to do with Node.js, but we'll see package.json listed here as well inside of Backbone. So this package.json file, even though it came out of the Node.js culture, is something that's been embraced by client-side library developers as well. There's no good reason not to gather that metadata somewhere. And if you throw it in a package.json file in the root of your source tree, that's where folks are going to begin going to looking for that kind of stuff. They're going to expect to see it there. So, coming back to this idea of requiring in libraries, if I see code that looks like this, requiring in FS, that's the file system library. That's part of native Node.js. And that allows me to do things like read dir. Now, dir name is a magic variable. That's the current directory I'm running in. But right afterwards, I see that event handler. You're going to see this pattern show up over and over again. JavaScript's not just a little bit asynchronous. It's asynchronous all the way down. And so when I'm trying to read out the files in that directory, I'll end up seeing something. If I want to run it, I'll end up seeing something that ends up looking like this. So there's the code we were talking about right here, bringing in a file system, wanting to read things out of this. If I come in and I do a node of all the files and directories. Yeah? But let's suppose that rather than using the built-in library, file system, I wanted to bring in an external library. So there's a library out there called Find It. Just pulling it out of the air. What I love about NPM is that it gives me a snapshot of how many times it's been downloaded in the last day, in the last week, in the last month. So I can begin telling if I'm dealing with abandonware, if I'm dealing with something that's very vigorous. When there are 30,000 NPM libraries out there, one of the things you want to do is a bit of due diligence to make sure you know who wrote it, if it's an 0.0.1 version and it hasn't been updated in the past 2 years, and it's only been downloaded twice, once by the author and once by his mother. Yeah, then we know that this is probably not a library that you want to use. But if I wanted to, I could turn around and do an npm install, find it, and if I throw /save on it, it will end up writing that to my package.json file as well. So rather than install it, what's especially nice is if I just checked this out, I could do an npm install. Not npm install find it, not npm install a particular library. I could just do an npm install, and it would go into that package.json file, find all my dependencies in that package, and download them for me. So this is another reason why that package.json is so important. By listing out your dependencies, you can have npm install it and run it on its own. Yeah? Cool. So if I were going to be doing something like this, begin seeing that I would require it once again. But I'm doing it all in one line. That find now is the method that I'm running, and it's asynchronous. And so I've got a number of different event handlers. If it comes across a directory, do this. If it comes across a file, do this. If it comes across a link, do this, and so on and so forth. So you begin seeing how this library is asynchronous as well. Good. Good, good, good. All right. So we've covered Node.js. We're dealing with server-side code. Are you ready to switch gears and move down to the client now? We're going to be doing the same kinds of things. We're going to be dealing with modules. We're going to be dealing with dependencies as well. But we're going to use a different library to help us manage that. No longer Node.js. We're going to be using a library called volo.js. And for those of you watching the clock, we're about... I'm looking forward to it as much as you are. So, Volo is a client-side library. But what I'm going to really talk about with Volo is this module concept once again, this dependency concept once again. So Volo is a library. In order to install it, what you end up doing is you end up typing npm install Volo. But if you throw that -g at it, what it does is it installs Volo as a global library. So that means anywhere from the command line, you can type in Volo commands, and they will be installed globally on your system. You will almost never want to install libraries globally for production web development. You want to have all your dependencies defined within that package.json. But for command line utilities that we're going to use, developer utilities, you almost always want to install them globally so you can use Volo across all of your projects. So you can use Uglify across all of your projects. So you can use JSLint or JSHint across all of your projects. So now what we're using is we're using Node.js to run a set of client-side libraries that we can use to manage our dependencies. Do you follow all that? Yeah? All right, good. So let me emphasize this once again. Volo is completely orthogonal to Backbone or Angular or Ember or Knockout or jQuery, any other library that you use. This is not a web framework. This is simply to help us with scaffolding and with dependency management. So if I were to type in npm install Volo right now, the very next thing I could type in was Volo create foo, Volo add foo, good things like that. Which is exactly what we're going to do. If I wanted to create a new application now, I could type in Volo create and the name of that app. Now, one of the reasons I like Volo so much is you can create your own templates. If you wanted to, and you just typed in Volo create foo, you're going to get an empty directory structure that has no JavaScript libraries in it other than Requirejs. But if you wanted to say, every new web app that we roll out in my organization includes Twitter Bootstrap, jQuery, and Backbone. Well, what you could do is you could create a set of templates, and then you could say, Volo create foo, and please use this template. Now that template, if you just define it like this, Volo's going to go out into GitHub and go looking for it. But what you can also do is provide your own URL, and you could provide your own file path as well. So on Windows, you could say Volo create foo /templates/my-template and use it that way. It's a very nice way for you to begin scaffolding out your application. So if I were to type out something like Volo create test2, it would turn around and use the default templates. How friendly the internet is this morning. Volo create git. Oh, it does, doesn't it? All right. Do I have a gits directory? There we go. So I'm sure I don't have a gits directory. So now I can type in Volo create gits. What it's going to do is it's going to reach out over the internet. It's going to look in GitHub for the default template, and it's going to lay it out. Waiting, waiting, waiting. All right. I know better than to anger the internet gods. I'm sure that will be positive. I'm being an optimist right now. Let's talk about what it should be doing, which is something like this. It should be scaffolding out a directory for me. Notice what it's going to do is it's going to give me a package JSON. We have to have that. It's also going to give me a www directory, that has a scaffolded out index.html, a www directory that has JavaScript folders for me and good things like that. It also brings Requirejs along for the ride. We'll talk about that in just a moment. But there are the templates that are available for you out there. Is it done? Let's see. All right, it's getting close. It's having to pull those bits all the way over from California, so it's taking a little bit of time. So when it creates a package JSON, it creates a stubbed out package JSON. You'll notice it doesn't create anything with a name, a description, semver, anything like that. What it does do is it gives you an AMD and a Volo package. So what I end up doing is I end up moving that off to the side, doing an npm init, building out a well-formed package JSON, and then copying those volo bits back in. So this with those volo bits back in it. Now, here's where I was expecting to be earlier. jQuery has its own package JSON. Backbone has its own package JSON. Angular has its own backbone JSON. Twitter Bootstrap has its own backbone JSON. So we can see that nearly every JavaScript library you're probably working with has its own package JSON associated with it. If you take nothing else away from this workshop, hopefully you take away the importance of package JSON. And now that's really fundamentally changing our industry. With JavaScript, we do now have a standard file that allows us to list out our dependencies, our unit tests, various things like that. Now, if I wanted to run a web server, one of the things I could do is I could bring in Connect. Connect is a third-party library. This is what the source code would end up looking like. Connect, I'm going to use these various things. I'm going to listen on port 3000. Here's the installation, npm install Connect. Are you beginning to see a pattern form here? A lot of what I'm trying to do is give you a whole bunch of different examples of how you end up using these kinds of things, so you end up getting comfortable with the syntax. But Connect brings us all kinds of different capabilities for logging, for gzip compression, handling basic authentication, a JSON parser, a multi-part parser, cookies, sessions, response times, static files, all those kinds of things. You would expect these to be a part of Node.js. In fact, what the HTTP package does is brings you a very simple web server. Almost everyone who's running Node in production is probably bringing in Connect to bring in these additional capabilities. So I would type in npm install Connect to save it, and this is what my web server would end up looking like. Now, I told you that Volo not only allows us to scaffold out a directory structure, it also allows us to deal with dependencies. And it's not really Volo that's managing our dependencies. The underlying library is Requirejs. And in fact, Requirejs is just one library of many that would allow us to deal with dependencies through AMD, or asynchronous module definition. So let's try to bring all of these concepts together. And if we don't get it done before tea time, that's fine. We can come back after it. But this is the next major thing we need to deal with. What is the responsible way to deal with dependencies as a web developer? Because as an industry, we've been irresponsible all this time. So the way you would add libraries through Volo now is you would say Volo add jQuery, Volo add Backbone, Volo add Requirejs, all of these kinds of things. Now this isn't going to work with any library under the sun. It's only going to deal with libraries that are AMD enabled. But you'll be surprised at what libraries out there are AMD enabled, starting with jQuery. Again, this is news to a lot of people. They're like, I use jQuery. I don't use Requirejs. I don't use AMD. And jQuery out of the box is AMD enabled. Now, I haven't defined what AMD is yet. We're going to come back to that. But I wanted to tell you that this isn't pseudocode. I typed in volo add jQuery, and it would pull those bits down. I'm not going to because I got kind of a crummy internet connection up here. You'll just have to trust me that if I typed in volo add jQuery, it would go out, grab the jQuery library, and put it in the right spot in my package. That's really nice. You have no idea how much these little conveniences add to your velocity as a developer. More and more libraries are becoming AMD enabled all the time, which would allow you to do this kind of thing. So, if I were to type type in volo add jQuery, this is what we would see. We'd see it's actually reaching out, pulling this stuff down. Remember, I don't have to always go to GitHub. I can type in volo add and put in any arbitrary URL, and it would pull down from my server. I can even put in a file path, volo add :/jQuery, and it'll pull the local bits down that way. So the convenience, the default, is to go looking for these dependencies in GitHub, but we're not tied to GitHub by any stretch. Once I did that, we would see now that jQuery is listed in here as my dependencies. I want to point out that we have two dependencies blocks, one for Volo and one for Node.js. This is because Node.js is going to be running your JavaScript server side. Volo is going to be running your JavaScript client side. So it only makes sense that we would want to have two different dependency blocks, one for our server-side dependencies, one for our client-side dependencies. As you'll see later on, we not only have dependencies, we have dev dependencies as well. You might need to bring in unit tests. You might need to bring in uglifiers and minifiers and things like that that are developer dependencies, but not runtime dependencies. So package JSHint gives you a way to be very explicit about all these different dependencies and where they snap into the life cycle of your application as well. So, let's come in here. If I had a better internet connection, I would go in and I would type in volo add thirsty head volo test. This is a library that I've posted out on GitHub somewhere. It doesn't do anything real interesting, but the reason I wanted to show you this is because my library, volo test, has a transitive dependency slang. And so by having my application have a package JSON and volo test have a package JSON, and in fact, slang have a package JSON as well, I can do transitive dependencies nested n-level deep. So when I install my package and it depends on volo test, npm will go out and install that for me. And if npm at volo test has a dependency of slang, it'll transitively bring in that dependency. And if slang has dependencies, it'll bring that in as well. In Java land, we end up using Maven or Gradle or Ivy to solve those kinds of things. npm solves that problem for us right out of the box. So when I go in to add that volo test, not only will it go out and pull down the volo test, it'll also pull down slang as well and install those things. Really nice. And again, once you get into the groove of this, you're just going to be expected. You're going to expect to be able to type in volo add foobar baz. When I was working at Time Warner Cable, I was there for about 3 years, helping them with their mobile HTML5 strategy. We were just beginning to roll out Requirejs and roll out these things. But Time Warner Cable had internal video libraries and had internal OAuth libraries and had different libraries like that. And so as we were doing web development, we were doing some Samsung development for Samsung TVs and some browser-based development. And there was also some iPad development going off on the same. Once we began doing development across different platforms, being able to do a volo add OAuth 2 and have it pull in that library across our different packages, it just became a huge time saver, a huge value proposition, how easy it was to include those libraries in different projects. We begin seeing a pattern form now that when I installed jQuery, it got dropped in the lib directory. When I installed volo test, it got dropped down there, and slang as well. So this directory hierarchy right here, anything in JSLib, is a third-party library that you've installed. Your code, your source code, shows up under the app directory. This is a very nice, subtle distinction as well. It's so helpful keeping your code separated from third-party code. We end up, many times, throwing JSLib in a .ignore in a .getignore file because we don't necessarily have to have those transitive dependencies hanging around. What we can do is we can type in volo.add and it will pull those dependencies down for us, just like npm install will do the same. And we begin now seeing our dependency block build up accordingly. So this is where I want to kind of circle back and really begin putting some definitions in place. Really make sure that we've got a solid understanding of what's going on with CommonJS, what's going on with AMD. Many people, when they're talking about these two, feel that they're competitors, feel that they are separate efforts that don't have a lot of overlap. And while I agree with the former, I agree with the latter less. They are two separate projects. They both grew out of two different inventors to solve two different problems. But they are more similar in spirit than other. CommonJS is what popularized this notion of packaged JSON files. CommonJS is what popularized this notion of semver. CommonJS is what Node uses. Anytime you're using an npm install whatever, you're using a CommonJS library. Now, that's all fine and good, but CommonJS is meant to satisfy your server-side dependencies. And because it's a server-side solution, it's also synchronous. Now that's all fine and good when you're on a server, when you have access to the file system. When I require FS, it's going to go out synchronously and pull in that hunk of JavaScript, interpret it, and add it to the execution environment. When I require HTTP, when I require find it, when I require connect, when I require express, all of those are synchronous calls. It's literally going to look in the Node.js directory for that file and read it in that way. That's the perfect solution for a server. It's an awful solution for the client. Because what happens if I require jQuery from a client? Well, I'm certainly not going to read it from the client's file system. That'd be nice. Wouldn't it be nice if jQuery just shipped standard in all web browsers? They would always be there? Yeah, it's not going to happen. But it would be nice. Whenever you include jQuery, what that has to do is that has to spawn a new HTTP request. And that's asynchronous by its very nature. And it's expensive as well. Every time you're reaching out and touching the network, it's expensive. Everything we do client-side, we try to aggressively cache it. We try to aggressively minimize the number of unnecessary HTTP requests we make. So what we find is client-side development has a whole different set of requirements than server-side development. And this is fundamentally the difference between CommonJS and AMD, asynchronous module definition. In a nutshell, we could say that Node.js is for server-side development and uses CommonJS for all of its dependency management. And CommonJS, by its very nature, is synchronous. When you're doing client-side development, we're going to end up using AMD, and that by its very nature is asynchronous. And so it's going to be more concerned about, well, do I already have jQuery? Have I already loaded that in a different page? If I do, I'm not going to regenerate that request. If you're using simple script statements, if you're copying and pasting the same set of script statements across the top of every file, your browser isn't going to say, oh, you've already got jQuery, I'm not going to re-request it. Of course it is. So we can bring in something like AMD to short circuit that, saying, oh, no, don't even worry about it, I got it right here. Here's what you're looking for. By Netscape, not created by Google or Microsoft or Oracle or anyone else. He just said, you know what? I'm not even trying to solve a technical problem necessarily. I'm just trying to say, how can we get together? How can we start putting together a common environment, a common way to start defining some of these dependencies? And out of that grew this whole set of common.js. One of the first things he did is he said, I need to figure out how to define modules. And once you define modules, you can go off and do all kinds of other things. You can start dealing with binary, you can start dealing with file systems, you can start dealing with unit testing, promises, if you've done any Ajax stuff, you know that promises are a way that you deal with asynchronous requests. But all of these are things that came out of the common.js framework. And there are a ton of people that are using that same set of common.js. Not surprising that Node.js is here among them, but I mentioned CouchDB earlier. CouchDB uses the same fundamental set of common.js modules that Node.js does. There's Narwhal, which was an older JavaScript kind of JavaScript-based thing. I do a talk later in the week on Ringo.js, which is a JavaScript kind of library. Node.js is running on V8. Ringo is running on the JDK. But you end up seeing there are a lot of different folks that are using this. But those are all server-side solutions. AMD now gives us the same way to install these modules, define these modules, but also deal with them through the full life cycle. And boy, that's a little bit hard to read, and I apologize about the color getting kind of blown out. But AMD has a variety of different implementations as well. We're using Requirejs, and we're using volo.js, which brings Require to the party. But if you've ever used Dojo, Dojo uses AMD as well inside of it. There's another library that's gaining a lot of mind share called curl.js. Curl.js is a very lean, very fast implementation. Requirejs was the original AMD implementation, so it's got a lot of mind share right there. But the folks behind curl said, we like what James Burke did with AMD with Requirejs, but we're going to really skinny it down and really optimize it. But we are using Requirejs. That's what Volo gave us. So when we see that Requirejs is a JavaScript file and module loader, great. When we see that it's optimized for in-browser use, And common.js actually predates AMD. AMD was written in reaction to common.js. So when they say that it can be used in other environments like Rhino and Node, we find that these aren't so different. And as a matter of fact, there's a way that you can shim your AMD modules so they can be common.js compatible as well. So ultimately what you end up with are a set of modules that can either be loaded up server-side or be loaded up client-side. Either be loaded up through common.js or be loaded through AMD. I'll give you some examples of that. It's literally just a little bit of boilerplate code. It is not hard at all to write a module that can be either loaded synchronously server-side or asynchronously client-side. Here's our good friend James Burke. So a lot of times in these presentations what I'm trying to do is just give you folks and specifically give you Twitter handles that would be worth following if you're interested in these kinds of things. You can imagine that following Isaac and following TJ and following James, if you were really interested in this Node.js stuff, these are the movers and shakers in that community, and these are the folks that are constantly posting, hey, got a new release coming, hey, added this feature, hey, fixed this bug. These are all good things that would be worth following. I've mentioned this several times. As JavaScript developers, we are going to have to learn these modules sooner or later. ECMAScript 6 is coming, and one of its, boy, we need a light bulb in here. This is really hard to read. One of its key features right in here is being able to not only define functions, this is a function with a point with XY coordinates. Down here, you're going to export that point. And then once you export it, so in point.js, I've defined a function. I'm exporting point, that function. And then in another file, I am importing that point. And then I'm newing up a point and doing other things with it. Again, as a Java developer, you're like, well, it's about time. I've been doing this since Java 1.0. Yeah, but this is a new concept and a critical new concept for JavaScript to be able to endorse. Now, the reason why we have to wait for ECMAScript 6 to become standard across these different browsers is you can see it introduces new keywords, the export keyword and the import keyword and the as keyword and various things like that. So ECMAScript 6 is on its way, and when it does finally get standardized, you'll use this kind of syntax. This is why it's so important for us to get comfortable with CommonJS, get comfortable with AMD, so we're comfortable with this idea of thinking in terms of modules, so when ECMAScript does come, you will have already been using these kinds of concepts. Think of CommonJS and AMD as polyfills or stopgaps, temporary solutions for this until the language itself provides a native solution. Yes?
How do you differ between the import versus export?
So the question is, if the same thing can be handled through a return statement, what do import and export bring to the party? Well, you can certainly return a value from that function. When you make that function call, you get a value out of there. But this import-export is a way that you can start bringing in an entire library. And implicit in this notion of modules as well, or you can have private methods and public methods as well. By saying export point, that means I am making that public, so the next time someone imports that, they'll be able to get at that point object. You can imagine, though, that there might be some internal helper classes, internal helper attributes that you don't want to be exposed out. And so it brings a new level of sophistication that you simply can't achieve with a simple return keyword. It's like return on steroids. Does that make sense? Yeah. It's a very good question. So there are a number of new keywords coming with ECMAScript. Let is another one that basically makes this thing final. So all of a sudden now, X is no longer mutable. We can't go in and change X from 42 to 43 or 41 or anything else like that. I don't want you to get too caught up on let, but if we define a module and then export X, then when we turn around and import foo, we can begin getting our hands on that. So a lot of fun syntax on its way. In the meantime, though, we'll end up dealing with CommonJS and AMD to get us there. So I have just a few minutes for you here. Let me show you what writing these modules looks like. And what I want you to notice here is we've got this exports. Now, when ECMAScript 5 comes out, we're going to be able to use that as a keyword. It doesn't exist as a keyword right now, so the way CommonJS deals with this is it defines a module class, and that module class has an exports hash map on it. And then you basically assign whatever values you want into that hash map. So this is what I'm talking about right here. There's going to be a very subtle but important change when ES6 does come out. Export will be a first-class keyword instead of a polyfill or a hack right now. But conceptually, it's doing the same kind of thing. If I have a file called info.js, if I don't export node version and platform, I won't be able to use it later on. Export is what's making that part of the public API. And by the same token, if I had a bunch of support functions in there that I didn't want to be a part of the public interface, I would simply not export them. But the fact that I've got a file called info.js, the fact that I've exported node version and platform functions means that later on, in addition to requiring connect, which is a third-party library, I can require info as well. And it's subtle, but I can tell as well that this is a local module, one that's defined as a part of my package, and this is a third party as well. So in addition to NPM installing Node.js and installing Backbone and installing things like that, I can turn around and require my own local modules as well. Once I've required info, I can call methods like node version and platform. Once again, this is the implementation, module exports platform. Here's the use. Once I require it, I can use it. Node version. Node version. Does that make sense? Yeah. So this is the CommonJS way of defining this. Please.
Can Node server-side Node.js or a different runtime also?
Interesting question. Can the server-side Node.js call a different runtime? So if I'm running in Node.js 0.8, can it call out to like a Node.js 0.10 or something like that? Is that kind of what you're asking?
Different language, different runtime, maybe thinking about a runtime.
So your question is, can Node.js call out to different runtimes like a .NET runtime or something like that? Absolutely. That's exactly what we're doing right here by executing SW versions or executing system info right here. This exact would allow you to turn around and run a Vbscript or run a PowerScript or run a shell script or whatever you want to do on this kind of stuff. So you're absolutely right. What you'd have to do is make sure that you could bring in a child process, but then you could turn around and spin up a child process and link to whatever you'd like. And your question was, so never assume that a client could run a Vbscript, because theoretically that client could be running not Internet Explorer but Safari. No JavaScript there, right? And if it's running Safari, chances are it's running on OS 10. No JavaScript there, right? So you would end up using this kind of child process on the server where you could ensure that Node.js is running on Microsoft Windows 7 that has a CLR in place, so I can run those various scripts, so I can make sure that F# is installed, or C# or Iron Ruby or Iron Python or whatever I wanted to do. So yeah, this would definitely be a server-side solution, so you can be sure that all those dependencies are in place. Does that answer your question? It's a very good one. Yeah. This is what a common JS module would end up looking like. Once we get back from our break, we're well caffeinated. We'll turn around and see how this looks from the client side. We'll come back and talk about AMD, and then in the last hour, we'll also have an opportunity to talk about hinting our code, linting our code, and uglifying our code. So lots of good stuff to deal with after the break. Help me out. Do we get back together at 11:15? Yes? So we have a good 10 minutes here, and if you need an extra 5 minutes because I stole it from you on the front end, we can do that as well. We'll get started officially at 11:20. Have a wonderful break. I'll see you back in 15 minutes. Depends on, and subsequently all of my dependencies depend on as well. So where we had left off is dealing with CommonJS, which gave us server-side dependencies. Now let's look at Requirejs, and just to bring you back up to speed, remember Requirejs is just one implementation that uses AMD. Dojo uses AMD, curl.js uses AMD. There are many implementations out there. We're focusing on just one. So in order to deal with dependencies in the client, normally when you're dealing with dependencies, you would do a script source, script source, script source. That's fine. That will always work, even in Requirejs. But what you have to realize is your browser isn't really very smart. If you say, I want you to go out and download jQuery, it says, okay, I'll download jQuery. And if you ask it to download it twice, it'll say, okay, I'll download it twice. And if you ask it to download it on the top of every single page in your app, it'll say, okay, here we go, right on, you told me to do this, I'm here for you, right? It's very eager and very faithful, just not very smart. So what Requirejs does for you is it brings some intelligence to the process. When I say from now on, you should only have one script tag in your head, and that one script tag is Requirejs, I'm saying that because now Requirejs is what's going to do all of your dependency management this point forward. Does that make sense? Yeah? Great. So when we bring in Requirejs, notice what it's looking for. It's looking for a file named app.js, and app.js is what we're going to end up using. Now app.js is where you can begin defining what your base URL is, paths, good things like that. But app.js requires in main. When you see this Requirejs, all of a sudden, that's what's bringing in that library for us. Whenever we see the require keyword used, you know that we're bringing in a new module. This module happens to be main, which is ours. This is where we're going to begin doing our requiring. Bear in mind, though, that this require should look very familiar to you. It's what's used in CommonJS. But this require is going to trigger an asynchronous download instead of a synchronous file system read. So if I were to go in and watch this happen right now, we would see my index.html file come down, and then we would see Requirejs come down. Because Requirejs asked for app.js, because Requirejs asked for app.js, we would see app.js come down next. Because app.js required main, we see main come down next. So you can see we can continue to download library after library after library. We can continue to require them in like we normally would. But the only time we want to use that script tag now is to bring in Requirejs. That's our module loader. Everything from that point forward needs to go through require instead of through the normal script tags. Does that make sense? Yeah. Great. So now, if I wanted to require jQuery, Notice what I'm going to do. I'm going to require jQuery like this, and I'm going to be able to use it all day long. When that happens, realize what we're doing here. We're doing DOM manipulation, right? We're selecting this paragraph, and after it, we're selecting the H1, and after that, we're inserting a new node inside of there. Anytime we're doing DOM manipulation, we are running client-side. But we're still using the same require keyword that we did using CommonJS. When I run this, not only do I see jQuery loaded, but I see now that I load Requirejs, which loads app, which loads main, which loads jQuery. And no matter how many times I require jQuery, I should only see it downloaded once, because that's what Requirejs is bringing to the party. jQuery is AMD enabled? Absolutely it is. This is source code right out of jQuery. It's saying, all right, if someone asks for jQuery, let's go ahead and return jQuery. We don't think of jQuery as a module, but it is a module. And when ECMAScript comes out, we won't be returning jQuery, we'll be exporting jQuery. And later on in your code, you will import jQuery, probably import jQuery as $, and continue going along. But that won't happen until ECMAScript 6 comes along. If I require jQuery and require volo test, and remember volo test had a transitive dependency as well of slang, when I do these kinds of things, now what I'll see is Requirejs, app.js, main, jQuery, volo test, and because slang was a transitive dependency, even though I don't require slang anywhere in here, because a library that I required uses it, that would trigger the download as well. Incredibly powerful. So, if you want to write your own AMD module, what you're going to do is define an object, and then at the very end, return it. So this is an AMD module that is going to return an object that has a platform, a vendor, and a user agent function call on it. What does that end up looking like? Well, when I require it, I can call the vendor method. Once again, there's my vendor method. And when I require it, I can begin calling it. So if you're looking at this code and you're saying, Scott, this looks exactly like my CommonJS code, exactly. That's the point. But the difference is all of my Node.js code is synchronous, all of my AMD code is asynchronous. But they're solving the same problems, just server-side and client-side. Step and merge these two back together. All you have to do is install a package called amdefine, server side. And by doing that, what that will then do is allow you to use require on both the server side and the client side. So, that is dependent. Yes, sir.
What's the scope of the required caching? How does it do per page, per website, or per browser also can be cached certain instances?
So the question is, and it's a very good one, the question is, when we're talking about caching, what does Requirejs solve? So Requirejs will definitely be running client-side, so it'll be running in a browser. So if I have your website pull up in Chrome and in Safari, I would still see two sets of downloads, one for each browser. And this is definitely on a per site basis. So if I'm visiting your site and my site, and we're both using jQuery, that's going to trigger two downloads as well. But this does manage all those dependencies within your site, within the browser. Very good? Excellent. JSHint with an H is a static code analysis tool. It was a fork of Douglas Crockford's JSLint project with an L. Now, JSHint is one half of what the JavaC compiler does for you. JSHint looks for simple syntax errors. Uglify.js, which is what we're going to talk about next, squeezes out all the white space and optimizes your code for production. But JSHint allows you to type in some fairly innocuous code. This is not a trick question. That is valid JavaScript. There are no syntax errors in there. What do you think JSHint has to do with that code? You're my visual linter at this point. What are you going to yell at me about? Semicolons, great. What else? No bars, right? I'm defining global variables. So yeah, absolutely. When I run through JSHint, it yells at me, missing semicolon, missing semicolon. First is not defined, last is not defined, all these kinds of things. So this allows you to do a lot of stylistic checking on your code without actually running it. This is a quote from Douglas Crockford saying, be careful, JSLint's going to hurt your feelings. And that's okay. It should hurt our feelings. So what's the difference between lint and hint? Well, lint is what got this whole ball rolling, written by Douglas Crockford. Now, Douglas Crockford is a smart guy. So when he says things like JavaScript is a sloppy language, but inside of it there's an elegant, better language, ironically also called JavaScript, right? He's a smart guy. This is his intent. As a matter of fact, he wrote a book about this called JavaScript The Good Parts. And JavaScript The Good Parts is saying, this is everything that JavaScript allows you to do. Let's narrow it down to this subset of JavaScript, and these are the things you should be doing. That's basically what his tool is doing. JSLint is an executable version of his book. Yeah? The only drawback to JSLint is it was Douglas Crockford's opinion of what that subset of JavaScript was. Douglas Crockford is very opinionated, and his tool was very opinionated as well. The other drawback was JSLint originally was just a website, so you could copy and paste your code into his website, but you couldn't make it a part of your continuous integration solution. So for those two reasons, you couldn't run it server-side, and you couldn't adjust the rules. Was the whole reason that JSHint came to life. JSHint was a fork of Lint, and they said, we do everything that Lint does, but we're tunable, so you can relax some of the rules. And they released it as a node module. So in a nutshell, JSLint is a very strict tool, and it was website only. JSHint came around, gave us flexible tools, and installed it as a node module. Then guess what? Douglas Crockford came around and said, yeah, I can do all that stuff as well. So now there's virtually no difference between hint and lint. Both have tunable tools. Both are NPM modules. Remember when I said one of the nicest things about the NPM website is you can see what the downloads are? This is JSLint. This is Douglas Crockford's tool. Downloaded 11,000 times last month. Well, that sounds pretty good. Oh, JSHint. Downloaded 83,000 times last month. So I would use either tool. I would use whatever tool you're already using. But again, knowing that you can go up to the NPM website and see which one is more popular, see which one is being used more, that might sway you in one direction or the other. But this is what installing JSHint ends up looking like. I'm going to do an npm install JSHint, but notice what I'm doing. Instead of doing a --save, I'm going to do a --save dev. And what that's going to end up doing then is drop JSHint in dev dependencies instead of dependencies. Dependencies are now runtime production dependencies. I have to have AM define. I have to have connect in order to run this in production. But JSHint is simply a developer dependency. When I type in npm install, it'll pull down both sets of dependencies for me. But I have further clarified this in my package JSON. This is what it would end up looking like running it from the command line now. If I run JSHint from here and run it over my app, it's going to yell at me about all those missing semicolons and everything else. But you can see it's doing it from the CLI, which means it can be done through Hudson or Jenkins or Bamboo or anything else. Very powerful. Notice what I'm running this on? I'm running this on jQuery. I do this every once in a while because whenever JSHint hurts my feelings, I run it on a third-party library like jQuery. It makes me feel a whole lot better about my code. jQuery, there's nothing wrong with jQuery at all. These aren't bugs. These are stylistic differences. This is Douglas Crockford yelling at the jQuery folks saying, you should be better about your code. Makes me feel better about my code. All right. So, let's see here. For the interest of time, I wanted to just point out to you that this is tunable. You can turn these rules on or off, and there are a variety of ways you can do it. You can create a JSHint RC file. That's typically what I do. I create a magic file that has my rules defined in it. But you can also do this inline in your actual document itself. But if you leave this forgetting everything else, remember this rule, ASI, automatic semicolon insertion. It's valid JavaScript to leave those semicolons out. The JavaScript runtime will automatically insert those semicolons. So you can stylistically decide if you want to have JSHint yell at you for not including semicolons or gracefully move on to the next set of stylistic rules that you've broken. So ASI is probably the number one hint you're looking for out of this. JSHint as well is really nice because it defines a number of environments. So if I'm running inside of Couch, I might say that I'm running inside of Couch, and that way it'll give me the default libraries that Couch is assuming. If I'm running in Node, it'll give me that default set of libraries. If I'm running jQuery or MooTools or Dev, it's going to give you a default set of includes, a default set of rules that are fine-tuned for that particular environment. JSHint's a really sophisticated library. You can even turn around and tell it to ignore files, include files, do everything that you wanted to do. We could spend an entire day just fine-tuning JSHint. I want to move on to uglify, because that's the same side of the coin. You certainly wouldn't want to run your code in production without hinting it, but you definitely would not want to run it in production without uglifying it. So, With apologies to the grown-up language, that's the name of the website. I didn't make that name up. You can't yell at me about this. It's a very nice website, though. If you go to this URL that I will not pronounce for the polite among us, it's a great resource for lots of new libraries out there. And they said, wow, we are really excited about this new library out there called uglify.js. It's a brand new compressor for Node.js. And what's interesting, compressors, minifiers, we can use those kind of interchangeably, have been a very popular part of web development. But ironically, they were not written in JavaScript. I was a big fan of the Yui compressor. The Yui compressor was actually written in Java. So I would include it in my AMP script. As I was building wars, I would turn around and use the Yui compressor to minify all of my JavaScript code. But do you see what it's doing? It was bringing a new dependency to the party. And if you're doing .NET development, you wouldn't want to bring in a whole Java environment just to minify your code. So you would end up looking for a C# implementation of some kind of compressor. And if you were in Ruby, you'd look for a Ruby implementation. And so this is why they were so excited. They're like, finally, we've got a JavaScript implementation of a compressor. So now all of a sudden, this is just as cross-platform as everything else. This is what your minifiers will end up doing. They'll end up removing the white space. They'll end up shortening your variable names. They will join variable declarations. They'll remove brackets. They'll do all of these things wherever it can. And if you think about it for a moment, this is exactly what a compiler typically does. I'll never forget one of the students in my beginning Java class who told me, I never add any comments to my code. That's what makes it run so fast. Do you believe that for a minute? You shouldn't. That's one of the number one things that the Java compiler does is it strips out those comments. But JavaScript is a very different beast. JavaScript is not a compiled language. It's an interpreted language. Which means that if you have a bunch of comments in your code, that comment gets downloaded down to the client. That comment gets stripped out by the client on the server side. You could conceivably be slowing down your code, not in terms of execution, but in terms of downloading and parsing if you've added copious comments throughout your code. So am I here to tell you should never comment your JavaScript code? Maybe Venkat would tell you that kind of thing, but I would never tell you that kind of thing. What I would tell you to do is minify your code so the comments are there for the developer convenience, but they're not there for production. That's a very important point. Please, yes?
Does it add the semicolon also? Because I think it does not add the semicolon, so it puts it to the previous line.
It's a very good question. I don't know if it does the automatic semicolon insertion or not.
Otherwise, there will be a syntax error. It joins two lines and then semicolon is missing.
Well, yeah, then it would definitely have to do that. One of the things, so I'm gonna revise that. It almost certainly has to insert semicolons where we didn't add them because it's stripping out all the new lines and the white spaces in there. So I'm going to revise my statement and say absolutely, it's going to be inserting the semicolons that you don't. Very good question. Very good question. Yeah.
Can we use JSHint or apart from Node.js?
So the question you're asking is, can I use JSHint and uglify.js? And the answer is absolutely yes, because there are two different libraries that serve two different purposes. JSHint is what allows you to make sure that your code is syntactically correct. What uglify, then obviously you have to run it inside a node. Yep, excellent. I'm sorry? Yeah, you can't use a node module outside a node. Yeah.
We have jQuery in Nodejs, and we also have Untitled. Now, which one would you suggest to use?
So this is a very good question as well. What I'm going to recommend you do is include non-minified versions of all your third-party libraries and let Requirejs do the minification on it. This is very different than what most people do. If there's a minified version of jQuery, they would include that in their project. But what Requirejs will do is not only minify these things, but it will concatenate all of them together. And so what I would typically do is include the non-minified version for development, and then let Requirejs minify everything at once. But you can override those things, you can include and not include, you can do all those kinds of things. But yeah, Java developer, this is what my development process ends up looking like. I write my unit test first, right? Of course I do. Yep. And then I write person.java. And is this what I put into production? You can't run Java source code, can you? You've got to compile it. And what the compiler does is it takes that person, it makes sure that there are no syntax errors, it strips out all the white space, all the comments, all the variable names, all of those kinds of things, and that's what you end up with that class. Java-C does quite a bit of manipulation to get from your source code to your executable code. Now, as well, we might end up taking a bunch of classes and jarring them up and take a bunch of jars and war them up and take a bunch of wars and ear them up. I mean, we could go on and on and on with that. But the important thing is there's a big transformation between the source code and the executable code. So how does this look in JavaScript land? How many of you think that's what it should look like? No one should raise their hands. It's a trick question. It's a trap. Don't fall for it. Right? And yet, this is what most people do. How many of you have ever SSH'd into a server and made a live change to any of your JavaScript code? Yeah, a couple of you raising your hands like this, right? Yeah, we shouldn't be doing that, should we? Nah, we shouldn't be doing that at all. So when the when the Java compiler does all this stuff for us, what we find the JavaScript minifier does as well. So getting back to our good friend jQuery, unminified, it comes in at 250K. Minified, it comes in at 95K. So you can see what that minification process does. It still will execute identically. But that minified version down there has none of the new lines, none of the white space, none of the comments, none of any of that kind of stuff at all. So these are the kinds of things we want to do because we want that to be downloaded to the client, not that. But I do want this in development. I do want to have all the comments and all the friendly variable names and function names and things like that. So we have two options. We could have an intern go through and change all the variable names and strip out the white terms. That's why we have interns, right? Yeah, or we could have an actual application do that for us. And this is where, it's a pity Neil Ford isn't here. If you want to get him all fired up, just mention the word transpiler to him and he'll get all tense and upset. He's a dear friend of mine. He hates this word. I kind of like it. Because compiling code takes one format and gives you something else. Takes a .java file and gives you a .cliss file on the other end. It's a transformation process. The transpiler is a transformation process as well. But instead of going from Java to class, or from .c to .exe, you go from JavaScript to JavaScript. So the idea behind a transpiler is it's more of an optimization, it's more of a translator compiler. Transpiling came about through CoffeeScript, because what CoffeeScript is it's a different syntax, but it transpiles into JavaScript. So essentially what we're doing is we're taking our JavaScript and transpiling it into JavaScript, but better JavaScript, more well-formed. What's interesting is that JavaScript is becoming the assembly language of the browser. There are dozens of languages that transpile into JavaScript. CoffeeScript is one of them, but we've got all kinds of different things. And what's especially interesting is you've got something like Dart, which gives you kind of a C Java-like syntax that transpiles into JavaScript. You've got TypeScript, which is a Microsoft project that gives you strongly typed JavaScript. So we've got some transpilers, some languages out there that bring strong typing to what's fundamentally a dynamic language. You also have things that add new concepts at JavaScript. So like Objective-J, if you're doing any C development, it's going to bring language extensions to the party. But this is what I find most interesting. There are projects out there that will allow you to take any of these other languages and transpile into JavaScript. So you could write Ruby and have it transpile into JavaScript. Have any of you done any GWT development, any Google Web Toolkit development? GWT is written in Java, but it transpiles to JavaScript. So this idea is not a new idea. This is what I love the most. There's a project out there called Project Narcissus. You know the Greek myth, Narcissus? He fell in love with his own image in a reflecting pool there, that he actually died staring at his face because he never wanted to go and eat or fall in love or do anything else. He loved himself so much. So what is Project Narcissus? It's a JavaScript runtime written in JavaScript by the inventor of JavaScript, Brendan Eich. So it's a wonderfully named project. Why on earth would we want a JavaScript engine written in JavaScript? So you can start having new language support in your browser without needing a plugin. If you wanted to run Ruby in your browser right now, you'd have to have some kind of Ruby plugin that did that. But what if you had a JavaScript runtime that accepted Ruby as an input and transpiled to JavaScript on the other end, and it was written in JavaScript? That means all you'd have to do is bring in a new library, and all of a sudden you can write JavaScript in your browser. Brendan Eich was doing this. I saw him demo this live. He had 3 script blocks. One script block had JavaScript in it. The next script block had CoffeeScript in it. The next script had Lisp in it. All 3 of those were native languages, 0 plugins, but used Project Narcissus to transpile those languages into JavaScript. This is a powerful idea. This is a powerful idea. So this is really what our JavaScript lifecycle should look like. We should still start with our unit test. We should write our JavaScript. But rather than pushing person.js into production, what we should do is lint it, and then concatenate it, and then gzip it, and then put far future expires headers on it. And this is what production should look like. Yes?
Yeah, does JSHint impose PMD rules?
Ask me one more time, I'm sorry.
Does JSHint impose PMD rules like in Spring? Does it
What you're asking?
PMD rules that can be imposed in Spring framework?
This is totally orthogonal to Spring. So this would do nothing on Spring whatsoever. You'd start looking at your Spring build tools to end up doing this. We're in strictly JavaScript land at this point.
Yeah, but PMD rules are generic, like PMD rules are not Spring specific, those are generic rules.
Sure. But those rules really don't have anything to do with you. Those rules would end up be snapping into a different part of your build process. Fair enough? Yeah. All right. So, scaffold out our directory structure. We've used volo to add in new dependencies. We can now use volo to build out. And by building out, what we mean is that volo ships with native uglify support. So just like we did an npm install volo, we did it with a -g to install it globally. We know that volo brings Requirejs along for the party. This is what we were doing for all of our AMD dependencies. By typing in volo build, it's going to defer to Requirejs to do all of the concatenation and minification that we need. Now, it ships with uglify.js by default, but if you wanted to, you could bring in the closure compiler. Now, the closure compiler was written in Java, so that brings a whole different set of dependencies, but it is nice knowing that these things are pluggable. So when we're doing this kind of thing, essentially what we would be doing here is we're saying, all right, I've got a www directory, but I want to make a new www built directory. And what I want to do is I want to run all my dependencies through this RJS that comes along with require. Looking like is this. I now have a project called Test2 that has a number of client-side dependencies. It has a number of server-side dependencies, has some developer dependencies as well. But what I'm specifically interested in are my JavaScript files that are unminified right now. I've got a bunch of JavaScript files in here that have comments, that have new lines. If I go looking around in here, we can see that some places I'm using semicolons, some I'm not. So I've got all of these files right here. Now I do have a www built folder here as well. Let me move that out of the way temporarily. Just to show you that if for some reason due to faulty networks or bad things like that, if these things don't work out, we'll still be able to look at that. But if I do a volo build right now, what it's doing is it's using my dependency tree that I defined to go through and find info and then main and then app, then jQuery, then require, then slang, then volo test, all of these kinds of things. I have got this transitive dependency tree. It will only include libraries that I'm actually using. In Java, I can import as many libraries as I want, but if I don't ever use a particular library, the compiler will strip that out. In a browser, if you're using script tags, you can blithely copy and paste them into the top of your file. You might import a library and never use it. And that's wasting everyone's time, isn't it? It's wasting bandwidth, it's wasting CPU cycles, it's doing a lot of things like that. So by using a good dependency management library like AMD, I know what libraries I'm using. And so it will pull in all those libraries. It'll concatenate them to a single file, and it'll minify them. So if I go looking now in my www built directory in my app.js file, let's take a look at app.js. This is every single one of the JavaScript libraries I've used in my application. This is jQuery, this is Requirejs, this is Slang, this is volo test, this is all of this stuff. It almost looks like assembly code, doesn't it? This is what I would want to download, is that single file. Now what's nice is that Volo still leaves all of my other files hanging out as well. It's now minified them, but it's left them in place. So if anyone accidentally was still using script tags, if anyone accidentally stepped out of Requirejs and was doing the old school way of script source equals, those files are still in place. But if you've done the right thing, they're hanging out at the server, but no one will ever make an HTTP GET request. The only thing that will get requested is app.js, which has all of our dependencies concatenated and minified into a single file. Does that make sense? Excellent. Excellent. Yes?
So does the whole file get generated in the first call to the server, require call comes to the server, or on need basis a part of
Not something I would do in runtime. This is something that I would do at compile time. So what I'm doing is I'm doing all this concatenation and minifying ahead of time, and then what I deploy to the server is the concatenated minified file, not the unminified stuff. So this is what gives me the best of both worlds. I have all of the friendly variable names, all the new lines, all the comments in development, but in production, I have a highly optimized file that's unreadable to the human eye, but it is as optimized, it is skinny down as possible.
But the cost would be that if a part of our website needs JavaScript, which never get used in the current workflow, it will still get downloaded even otherwise.
If you're using script tags, they will. If you never require it, it'll get excluded from this process. So that's the difference. Yeah?
What about the namespace conflicts? Like, for example, various JavaScript libraries are probably using the same kind of a shortcut or a shorthand. In those scenarios, how is it really going to resolve? I mean, is it going to resolve the question?
You will run into problems at some point. And there are ways that you can end up excluding. A lot of times that's the simplest thing to do. There are some libraries that we end up using that aren't AMD enabled, and what we would end up doing then is we'd end up using the script tag like we normally would, but we end up doing that by intent. We're saying, all right, I'm going to exclude this library from the AMD process. I'm going to use it as is, but all my other stuff, certainly all of your code, all of your application code, should be AMD enabled so it can be minified and concatenated like this. Very good questions.
When suppose two files have same function, after putting all together in one file, then it can become conflict or something.
So the question is, what happens if I've got two JavaScript files that have the same function name or something like that? That's a problem in JavaScript in general, isn't it? If you import a.js and b.js and they both define a function, last man wins. The last one that you import wins. So that would be a bug in your code, regardless of whether you're using Requirejs or not. Yeah. So, Require and app and jQuery and slang and all these other things like that. This is what you would want to end up with. At the end of the day, you want to reduce the number of HTTP requests you can to the bare minimum. You want to concatenate all those files. And so when I look at this now, this is a highly optimized website. I'm downloading Requirejs because I have to, and then everything else has been concatenated and minified into that file. So, if you wanted to install uglify outside of Volo, you certainly could. It's obviously a very popular library. And by doing this, you could end up doing a number of different things. It's certainly a dependency library, not a production library. But you can turn around and use uglify to read from a standard input. You can turn around and use uglify to transpile your own code. You can turn around and use this to beautify your own code. There are lots of additional things that you can do outside of what this does. As you can see, you can decide to leave white space in place or shrink it out. You can leave comments in place or shrink it out. You can mangle your variable names or turn it off. So by installing this library, what you're doing is you're introducing the full power of the library to you. So this would be an example right here of us wanting to turn around and just beautify a file. So if we hadn't indented things, if we hadn't inserted semicolons, things like that, we could turn around now and we could just run beautify, and that would pretty up our code. So Volo is giving us all of these kinds of errors like that, but eventually we would end up with pretty code at the end. In the last 5 minutes we have together, I want to give you just a hint of what we can do with unit testing. So in the last 5 minutes together, let's talk briefly about one of these sections that I was talking about. We could end up talking about all day. Unit testing is a really important part of the development process. I'm really glad we had a little bit of time left over to hit this. So one of the first JavaScript testing libraries I got exposed to was JSUnit. JSUnit was a simple port of JUnit into JavaScript. So I could do all the assertions that I wanted to do. I liked that because I already knew JUnit, so this was another library I could use. But then I got really bit by this BDD bug, this behavior-driven development bug. And I came across Jasmine. And Jasmine allows you to use a different syntax that ends up looking more like this. Instead of doing assert this and assert that and assert the other, I can say it contains a spec with an expectation. I'm expecting true to be true. You can see that it brings a different bit of syntax, even though if I said assert equals true, true, I'm getting the same done. I've got a little bit of different syntactic sugar out of this. Now, as a contractor, when I'd go to my clients, I would end up having to say, well, I would think that we'd want to use this, and then they say, no, we really like this other library. We like this style or that style or the other. And so given that, that's when I discovered not Jasmine, but Mocha. Because what Mocha is as a testing library is a pluggable testing library. I can plug in different assertion styles. So I can do JUnit style assertions or BDD style assertions. It's pluggable in the sense that I can run it in Node or I can run it in the browser. It's pluggable in the sense that it supports plugins as well to make things easier, like asynchronous testing and things like that. So Mocha.js is something you should look at if you don't have another testing library that you're always fond with, because it hits on all the right notes for me. Server side, client side, whatever assertion style you like, whatever reporting style you want on the other end, all of this stuff is pluggable.
How is it different from QUnit?
How is it different than QUnit? So QUnit has a specific style and syntax in here. QUnit you can end up using inside of assert.js, or inside of, mocha.js if that's what you wanted to do. So what that ends up looking like is this is using an assert library that ships standard with Node.js, assert. So I can run this kind of unit test inside of Mocha without any problem. Installing Mocha like that, it's certainly a developer dependency, not a production dependency. Now, that assertion style is nice, but what if I wanted to turn around and bring in another assertion library like chai? What chai would allow me to do is do things like it should be equal, not assert, assert, assert in there as well. Now what's nice is that chai allows me to do the same assert equal kind of styles as well as the BBB styles. You were talking about QUnit. It allows me to do QUnit kind of styles in here. So when I look at Mocha and I look at chai in combination, they're kind of a meta testing library that gives you the flexibility to make it match whatever assertion style you'd normally like. So chai is an installation process as well. So I would install Mocha and then I would install chai. And what's ironic is chai supports a bunch of plugins that I would turn around and insert as well, npm install this, that, and the others as well as it goes along. But at the end of this, and this is where I'm going to leave us for the day, when we're doing unit testing, all of these are doing exactly the same kind of thing. Whether I'm saying foo should be a string, or I'm saying expect foo to be a string, or I'm saying assert type of foo string, at the end of the day, I shouldn't much care what syntax I'm using. I'm writing those unit tests, and they're all doing the same basic thing. So if you end up using a library that gives you the flexibility to pick your assertion style, it really brings a lot of power to the party. When you download this slide deck, you'll see at the very end, I give you the recipe that you need to write unit tests that will either run server-side using CommonJS or client-side using AMD. But I'm going to have to leave that as an exercise to the reader, because if I kept talking, I would be taking away valuable time from my dear friend Dr. Subramaniam, who is going to be talking about HTML5. Did you enjoy yourself this morning? I certainly did. Thank you so much for your time and your attention. I appreciate it.